So, in a previous video, we looked at the cars that are turning in roundabouts or corners, where we use the circular motions equations to find out the maximum speed at which they can travel at the corner. And we came up with a formula that depends on the friction, which determines the maximum speed they can travel on. But when you look at these race cars or these tracks where we have got the cyclist, we want to find a way to achieve a greater speed in a smaller circle, because we can't have acres of land for these tracks. So how do we achieve a high speed? What we do is these banked roads. Like if you look at these roads from here, there's a slope and there's a slope. So that means that the normal force, a component of the normal force, will provide the centripetal force. That means that component depends on the angle. So just like that, we rely on friction in horizontal surfaces. In bank roads, it depends on the angle. The speed at which we can travel on, it depends on the angle. So let's write the equations that we need to find out what the angle should be to achieve a certain speed. So we have a car here, and that's going on a bank road. So this is like the one here, or a track here. So the weight is downward, and the reaction force or the normal force is always perpendicular to the plane where the object is. And then we have the centripetal force, which is towards the center of the circle. So the centripetal force is provided by a component of the normal force. So in this case, that Fn sine theta is a centripetal force. And what we're going to do is that Fn cos theta is equal to mg. So we know the vertical component and we know the horizontal component, and we're going to use that to find the speed at which we can travel on the road, the maximum speed when the angle is theta. So let's write those equations now. So when we use the Newton's second law vertically, we find that Fn cos theta is equal to mg. So let's say this equation 1. And horizontally, the centripetal force is the horizontal component or the of the normal force. So that means Fn sine theta is equal to mass times acceleration, mv square over r. So now from equations 1 and 2, if we divide 2 by 1, so Fn sine theta divided by Fn cos theta, let's write that down. So Fn sine theta divided by Fn cos theta is equal to mv squared over r, mv squared over r divided by mg. So what's going to happen, that mg, Fn and Fn will cancel out. So sine theta over cos theta, tan theta, and this m and m will cancel each other. So we'll get tan theta is equal to v squared over rg. So that means v squared is equal to rg tan theta. So that's the equation that that relates the speed and the radius and the angle. So angle is the one mainly that decides, angle and the radius of the circle, that would decide what is the maximum speed at which you can travel on the roads. So if you are asked to design a road, or the main thing is that you are given the radius or the area, the land that's for the track, and you need to find the angle to achieve a certain speed. It's a racetrack, and for the cars, so 300 kilometer per hour, we need to achieve that speed. And what should be the angle? And if the radius is say 200 meters, so all that you need to do is that you need to put the speed here, and you got the radius, and you got the gravitational acceleration, and you can find the angle. So you find the angle and you tell the council, well, if you want to achieve that speed, and this is the angle for the bank road.